Ready to jump into Python. We're taking a deep dive today. And I know you're here because you want to learn Python quickly and get things done.
And we're here to help you do just that.
Yeah, it seems like Python is everywhere these days. Websites, data science, even AI, you name it.
It's true. It's incredibly versatile.
Yeah,
But how can you get up to speed quickly? That's the real question.
right. So why is Python so popular in the first place? Especially for someone who's ready to hit the ground running, like our listener.
Well, I think a few key things make it really stand out. For one, the syntax. It's super readable.
Readable.
Yeah, almost like plain English.
Mm.
Way easier to learn than some of those languages with, more cryptic syntax.
So less like trying to decode some ancient scroll and more like reading a straightforward instruction manual.
Exactly. And on top of that, the community is huge, and it's so active. There's a ton of support out there.
Ah, that's great. Especially when you're new to coding and might feel a little lost, you need that support.
Oh, absolutely. And then there are all the libraries, pre-built tools to make coding even more efficient. Think of it like a toolbox.
Full of specialized gadgets. Okay, so we've got readability, great support, and a pre-stocked toolbox. No wonder it's so popular. But hold on a second. With all those resources out there, how can our listener approach learning Python strategically, especially if they're aiming for fast results?
You're right, it can be overwhelming. It's all about structure, focus. You got to start by defining your objectives, right? What do you want to achieve with Python? Do you see yourself building websites? Or maybe you're into analyzing complex data. Maybe you want to dive headfirst into AI.
It makes sense. Having a clear goal from the get-go can make a huge difference.
It really does. Once you've got that goal, you need to be realistic about how much time you can actually dedicate. Even just 30 minutes a day, but consistently, that can lead to some serious progress.
Yeah, those consistent small steps, that's the key.
It is. And then explore the different learning resources. There are online courses, interactive platforms, even good old-fashioned books. Find what fits your learning style. Don't be afraid to try different approaches.
Of course, we can't forget the most important part, actually writing code.
Absolutely. Hands-on practice, that's where the real learning happens. Start with simple projects. Build a calculator, a text-based game, anything to get those fingers typing.
Build that confidence with those small wins and then take on the big challenges.
Exactly. And there are websites out there, like LeetCode and HackerRank, that have coding puzzles, like brain training for your coding skills.
Before we get too far ahead of ourselves, let's rewind a bit. Back to the basics. What are those fundamental building blocks that make up Python?
First up, you have Python syntax and data types. Think of it as the essential grammar and building blocks of the language, right? You got variables, strings, numbers, booleans, lists. These are your ingredients for your Python recipes.
So understanding those basic ingredients before you can start whipping up any fancy Python meals.
Precisely. And then you have control flow. This is how you make your program actually do things, right? Making decisions with if-else statements, repeating actions with loops. Essentially, you're giving your program instructions on how to behave.
So it's like teaching your program to think logically, to follow a specific set of rules.
Yeah, that's a good way to put it. Then you've got functions and modules. Functions let you write reusable chunks of code, kind of like building your own custom tools. And modules are collections of those pre-built functions, giving you access to Python's built-in toolbox.
This is where things start to get really interesting, building our own tools and using Python's built-in ones.
Exactly. And once you've mastered those fundamentals, the more advanced stuff becomes a lot easier to grasp. It's like leveling up.
That's encouraging. So let's say our listener has a good grasp of those fundamentals. What are some resources they can tap into to accelerate their learning? I mean, the online world is a goldmine, right?
It really is. You have platforms like Coursera, ADX, offering structured courses from top universities. Then there are sites like Codecademy and FreeCodeCamp. They're fantastic for hands-on interactive learning.
We touched on a few interactive platforms earlier, like Algocademy, Replo.et, and Jupyter Notebooks.
Oh, definitely add those to your toolkit. Algocademy and Repl.it, those are perfect for hands-on coding right in your browser. And Jupyter Notebooks, those are essential for data science work, where you can combine code, visualizations, and explanations all in one place.
And we can't forget the official Python documentation.
Absolutely not. The official documentation, it's comprehensive, it's constantly updated. Might seem a bit daunting at first, but once you're comfortable with the basics, it becomes your go-to reference.
The ultimate Python encyclopedia, always there to answer your questions.
Exactly.
Speaking of resources, we can't forget about the amazing Python community. I mean, that's one of the things I love, that sense of community, especially when you're learning something new.
Oh, it's a game changer. You've got online forums like Stack Overflow, dedicated communities like Reddit or LearnPython, even Python-focused Discord servers. Those platforms are awesome for asking questions, getting unstuck, and connecting with other learners.
It's like having a whole network of support, a place to share your struggles and celebrate those triumphs.
You got it. And if you prefer in-person interactions, check out websites like meetup.com for local Python groups. You never know who you might meet. Future coding buddy, maybe even a collaborator for a future project.
You're right. The right connections can make the learning journey so much more rewarding. So we've got the basics, the resources, and the community. Now let's talk about those specialized libraries that make Python even more powerful.
These libraries, they're essentially pre-written code modules for specific tasks. So they save you a ton of time and effort.
So instead of building everything from scratch, you can use these pre-built tools for common tasks.
Exactly. Like if web development is your thing, there's Django, super popular for building robust web applications. And then there's Flask, great for lighter projects.
What about our listener who seems interested in data science, machine learning? What libraries are essential for those domains?
Well, in data science, you've got NumPy, a powerhouse for numerical computing. Then there's Pandas, amazing for manipulating and analyzing data. And scikit-learn for implementing a whole bunch of machine learning algorithms.
Like having a data science Swiss Army knife.
That's a great way to put it. And for deep learning, the big players are TensorFlow and PyTorch. Those let you build and train super sophisticated neural networks. Think image recognition, natural language processing, that kind of stuff.
Wow, it's like Python has a tool for pretty much every job imaginable. But let's not get too far ahead of ourselves. We're eager to dive into these advanced areas, but first we want to make sure we have a strong foundation.
Makes sense.
What are some of the more advanced concepts that someone with a good grasp of the basics can start to explore?
One of the key concepts is object-oriented programming, or OOP for short. It's a really powerful way to structure your programs, making them more organized, reusable, and easier to maintain.
So you're taking those basic building blocks and using them to construct more complex and organized systems.
You got it. Then there are decorators and generators. Decorators are kind of like adding special features to your functions, modifying their behavior without changing the core code. And generators, these are special functions that produce a sequence of values, which makes them super efficient for working with large data sets.
Sounds like powerful tools for taking your code to the next level.
Oh, for sure. And then if you're working on applications that need to handle multiple things concurrently, you'll want to look into asynchronous programming that lets your program juggle multiple operations efficiently, making it faster and more responsive.
Like multitasking for your Python programs.
Exactly. Just remember, you don't need to jump into all these advanced concepts right away. Take your time, build a solid foundation, and then gradually explore these more advanced areas.
Sounds like a plan. Now, shifting gears a bit, let's talk about best practices for crafting good, maintainable code. Because even the most brilliant program can be a nightmare to work with if it's not well written.
You're absolutely right. And a lot of these best practices are actually similar to habits you might develop in other areas of life. Consistency is key, for example. Just like practicing an instrument or working out, coding regularly makes a huge difference, even for short periods.
So building those good coding habits early on.
Precisely. And just like you might learn from watching a master chef or a skilled athlete, you can learn by studying well-written Python code from open-source projects.
It's like having a coding mentor, right? Learning from the best.
Exactly. And, teaching is one of the best ways to solidify your own understanding, whether it's blogging, mentoring, or just explaining something to a friend. When you teach, you have to articulate your understanding, which helps you find any gaps in your knowledge.
I've definitely found that to be true. What about version control? How important is that for someone learning Python?
It's essential, especially if you plan to collaborate or work on larger projects. Tools like Git and GitHub, they let you track changes, go back to previous versions, and manage your entire code base effectively.
Like a safety net for your code. You can experiment without the fear of breaking things.
Precisely. And lastly, writing clean, well-documented code is crucial for readability and maintainability. Think of it like keeping your house tidy. A well-organized code base is so much easier to navigate and modify, both for you and for anyone else who might work with your code in the future.
Love that. Clean code equals a happy coder.
Absolutely. Now, even with the best practices in mind, learning anything new comes with its own set of challenges.
For sure. Python is no exception. But let's equip our listener with some strategies to overcome those hurdles.
Okay, let's talk about some common roadblocks. First one that comes to mind is information overload. With so many resources available, it's easy to feel overwhelmed and not know where to start.
It can be paralyzing.
It really can. The key is to avoid trying to learn everything at once. Focus on one concept at a time, build a structured learning plan, and celebrate those little victories along the way.
So break it down into manageable chunks and make steady progress.
You got it.
Yeah.
Another common one is debugging frustration. Let's face it, debugging, finding and fixing those pesky errors in your code, it can be a real headache.
Especially for beginners. It can feel like an endless loop of trial and error.
It can. But debugging is a normal part of programming. It's not a sign of failure. It's an opportunity to learn and get better. Use those error messages. Use print statements and debuggers, and see each bug as a puzzle to be solved.
Reframe those moments of frustration as learning opportunities.
Exactly. Now, let's talk about a challenge that's less about technical skills and more about mindset. Imposter syndrome. That feeling of self-doubt, like you're not good enough or that you don't belong.
A common struggle, especially in a field like programming.
It is. Just remember, everyone starts as a beginner. Everyone makes mistakes. Celebrate your progress, no matter how small, and try not to compare yourself to others. Focus on your own learning journey, and remember that every expert was once a novice.
So true. Speaking of beginners, let's address the challenge of lacking project ideas. It's easy to feel stuck after completing tutorials, not knowing what to build next.
I get it. My advice: look for problems to solve in your own life or work. What are some tasks you do manually that you could automate with Python?
Things like organizing files, sending emails, even analyzing data from a spreadsheet.
Exactly. Or maybe there's a website you use a lot that you could scrape for information using Python. Start small, find something that interests you, and then build from there.
Turn those everyday frustrations into coding challenges.
Exactly. And the more you code, the more ideas you'll generate. It's a fantastic cycle.
This has been such a great overview of Python. We've covered the basics, the challenges, and the amazing resources available. But for those listening who are learning Python to get a job in tech, what's your advice for them?
Right. Python skills are in high demand right now. But acing those technical interviews, well, that takes more than just knowing the syntax.
So what are some key areas to focus on to really stand out in those interviews?
First up, data structures and algorithms. Interviewers love to test your understanding of how to use those effectively in Python. So brushing up on things like lists, stacks, queues, dictionaries, and those sorting and searching algorithms is super important.
So it's not just about writing code that works, but writing code that's efficient and optimized.
Precisely. Then there's time and space complexity, often called Big O notation. This measures how efficient your code is in terms of time and memory usage.
So showing that your code can perform well under pressure.
Exactly. And then, of course, you need strong problem-solving skills. Technical interviews are all about showing that you can think critically and solve problems with code. Practice those coding challenges, but more importantly, be able to clearly explain your thought process as you're solving them.
It's like thinking out loud, letting the interviewer see your problem-solving journey.
You got it. And communication skills, they're just as important as your coding skills in those interviews.
Not just being a coding wizard, but being able to explain your magic.
Exactly. And for those aiming for more senior roles, system design is key. This is being able to design scalable systems, meaning systems that can handle increasing amounts of data and traffic without falling apart.
Taking your coding skills to the architectural level, designing systems that can stand the test of time and scale.
You got it. The great thing is, all of those skills, from data structures and algorithms to system design, they're all built upon that solid foundation of Python knowledge we've been talking about.
So master those fundamentals and then branch out.
Exactly. But never forget, learning never truly stops, especially in the tech world. Things are constantly evolving, and Python is no exception.
So how can someone keep their Python skills sharp and stay ahead of the curve?
So many ways. First, stay updated. Follow those Python blogs, newsletters, and social media accounts dedicated to the language.
Immerse yourself in the ever-evolving world of Python. Continuous learning.
Yes. And attending conferences like PyCon, that's an incredible opportunity to network, learn from experts, and discover new tools. It's like a booster shot of inspiration.
Connect with the Python community, share ideas, and recharge those coding batteries.
Precisely. And if you're looking for some validation of your skills and a nice boost for your resume, consider getting certified in Python. They can provide tangible proof of your expertise and show your commitment to continuous learning.
Like a stamp of approval from the Python masters.
You could say that. And once you have that solid foundation, think about specializing. Whether it's data science, web development, machine learning, whatever you're passionate about. Specializing can make you stand out on the job market.
Finding your Python niche, the area where you can truly shine.
That's a great way to put it. The Python journey, it's an adventure, and you get to choose your own path. Explore those areas that ignite your passion.
This has been an amazing deep dive into Python. From the fundamentals to advanced concepts, the resources available, and even tips for nailing those technical interviews.
We covered a lot of ground. Hopefully our listener feels ready to start their own Python adventure.
I think they do. Just remember, start small, stay consistent, and don't be afraid to experiment. Embrace those challenges along the way.
And never stop learning. The beauty of Python is there's always something new to discover and master.
So to wrap up this part of our deep dive, I have a question for our listeners. What problem are you going to solve with your new Python skills?
The possibilities are endless. We can't wait to see what you create.
Until next time, happy coding.
It's amazing, isn't it, how Python can be so simple, yet so powerful.
Yeah, kind of like those unassuming martial arts masters you see in movies. They seem ordinary, but then boom, they unleash this incredible skill.
Exactly. We've talked about what Python is, the basics, the resources, all that. But let's dive into why it's become so popular, the principles behind it.
Okay, let's unpack that. What's at the heart of Python's magic?
Well, one core principle is simplicity. Everything about it is designed to be as clear and straightforward as possible.
So it's less about deciphering some secret code and more about expressing your ideas, almost like you're having a conversation.
That's a great way to put it. And that clarity, it goes beyond just the syntax. Python emphasizes readability in its very structure. For example, the way you indent your code, those spaces at the beginning of lines, it's not just about aesthetics, it actually affects how your code runs.
Wait, really? The spacing determines how it runs. That's pretty unique.
It is, and this forced indentation, it kind of forces you to write neat, organized code, which makes it so much easier to understand and maintain.
I can see how that would be a game changer when you're collaborating with others. No more trying to decipher someone's messy code.
Exactly. Another principle is the idea of batteries included. Python comes with this huge standard library, that toolbox of pre-built modules we talked about. You can do so much right out of the box.
You don't have to reinvent the wheel for every task. You can just grab the right tool and get to work.
Precisely. This makes Python super versatile and efficient. You can accomplish a lot with just a few lines of code, which is perfect if you want to see results quickly.
Now, we touched on dynamic typing earlier. Can you expand on that a bit? How does that play into Python's design?
Dynamic typing is all about flexibility. You don't have to tell Python what type of data a variable will hold. It figures that out on its own.
So it's like Python is taking care of some of the bookkeeping, letting you focus on the more creative side of coding?
Exactly. This dynamic nature is a big part of what makes Python so adaptable. You can use it for so many different things.
Especially in fields like data science, where you're dealing with information that's constantly changing, that flexibility must be invaluable.
It really is. And that adaptability goes beyond just data types. Python is cross-platform, meaning you can write code on one operating system like Windows and run it on another, like Mac OS or Linux, without any major changes.
So it's like a universal language for computers, breaking down those barriers between different platforms?
You could say that. This portability makes it super versatile. Your code can reach a much wider audience.
Okay, so we've got simplicity, readability, batteries included, dynamic typing, and cross-platform compatibility. That's a powerful combination for any programming language.
It is, and it's a big part of why Python is so popular across different fields.
Speaking of which, let's focus on data analysis. Our listeners clearly interested in that. What are the steps to get started with Python in data analysis?
Well, first, you got to choose your adventure, right? What do you want to do with Python and data? Explore trends in social media. Uncover insights from financial markets, delve into scientific research.
Having a specific area of interest, that makes the learning process so much more engaging.
Well, for sure. Once you have a direction, then you can start exploring the right resources.
Okay, so what are some of those resources? What would you recommend for someone just starting out with Python for data analysis?
Online courses are a great way to go. Platforms like Coursera, ADX, DataCamp, and Udemy, they all have structured courses that can guide you through the fundamentals. Many of them even focus on specific applications or industries.
Like a personalized curriculum tailored to your goals.
Exactly. And they often include hands-on exercises, so you can apply what you're learning.
Learning by doing is the best. What about books? Any recommendations there?
Absolutely. Python for Data Analysis by Wes McKinney, that's a classic. It covers everything from the basics of Python to more advanced data analysis techniques using libraries like Pandas and NumPy.
Sounds like a must-have for any data analyst.
It is. And don't forget about online tutorials and documentation. Websites like RealPython and Towards Data Science, they have tons of free articles, tutorials, and even interactive notebooks.
So it's like having a digital mentor walking you through all the steps.
Exactly. And remember, the Python community is amazing. Online forums, communities, social media groups, they're all great for support and inspiration.
That sense of community makes a big difference. It's not so intimidating when you know you're not alone.
Definitely. And for a more hands-on experience, platforms like Kaggle and DataQuest offer data science challenges and projects based on real-world data.
So it's like a boot camp where you can test your skills and build your portfolio.
Exactly. They're great for gaining practical experience and getting feedback on your work.
This is making me want to dive into data analysis myself. It's so fascinating.
It really is. The amount of data out there is incredible. It's just waiting to be analyzed and turned into meaningful insights.
Speaking of which, let's talk about the essential tools and techniques for our data-driven listener. What are the must-haves?
One of the first things you'll want to get familiar with is Jupyter Notebooks. There are these interactive web-based environments where you can combine code, visualizations, and explanatory text all in one place.
So it's like a digital lab notebook where you can experiment, document your findings, and share your results with others.
Exactly. They're super popular in the data science community.
Jupyter Notebooks, check. What about libraries? What are the key players for data analysis?
Pandas is essential. It gives you these powerful data structures, like data frames, that make it really easy to manipulate and analyze data. Think of it like a supercharged spreadsheet.
So Pandas helps you wrangle that data into a manageable format.
Precisely. Then, for analyzing and visualizing the data, you've got libraries like NumPy, Matplotlib, and Seaborn.
Tell me more about those. What are their strengths and how do they work together?
NumPy, which stands for numerical Python, that's the foundation for numerical computing in Python. Arrays, matrices, mathematical functions, all that good stuff.
So if Pandas is like the toolbox for organizing your data, then NumPy is the engine that powers the tools.
Perfect analogy. And for creating visualizations, which are crucial for understanding data, you'll want to use Matplotlib and Seaborn.
Visualizations, yeah, those make it so much easier to spot trends, see outliers, and tell a story with your data. What's the difference between Matplotlib and Seaborn?
Matplotlib is super comprehensive. You can create all sorts of visualizations with it, static, interactive, even animated. You have a lot of control, but it can take a bit more code to get what you want.
So Matplotlib is like having your own artist studio with all the tools and materials you need.
Exactly. And Seaborn builds on top of Matplotlib, giving you a higher-level interface for creating visualizations. It's like having an art director who helps you make your visualizations more impactful and visually appealing.
Sounds like Seaborn can take your data visualizations to a whole new level. So now that we've got the basics of data manipulation, analysis, and visualization down, what are some more advanced areas to explore?
Well, one of the hottest fields right now is machine learning. It's all about building algorithms that can learn from data and make predictions or decisions without being explicitly programmed.
So teaching computers to learn from experience, kind of like humans do.
Exactly. And Python is the go-to language for machine learning. It has all these powerful libraries and frameworks.
Like what?
A good starting point is scikit-learn. It's very user-friendly and has a ton of algorithms for things like classification, regression, clustering, all those machine learning tasks.
So I could use scikit-learn to build a model that predicts customer behavior or categorizes documents or finds patterns in complex data.
Exactly. And then if you really want to dive into deep learning, where you're building artificial neural networks, you'll need libraries like TensorFlow and PyTorch. Those are the tools for building really sophisticated systems.
Deep learning, that's where the real magic happens.
This is a fascinating field, that's for sure. And Python is right at the forefront of it.
We've covered so much ground today, from the fundamentals of Python to the tools for data analysis, even a glimpse into machine learning. It's incredible what you can do with this one language.
It really is. And you don't need to become an expert in everything. Focus on what interests you, gradually expand your knowledge, and enjoy the process.
So build your Python skill set brick by brick, creating that foundation for all your data-driven ambitions.
Love that analogy. And remember, the journey is just as important as the destination.
Speaking of the journey, I'm curious about the broader impact of Python. We've talked about its technical side, but how is it shaping the world beyond coding?
That's a great question. It's definitely not limited to software development. Python's playing a huge role in some of the most transformative fields today. AI, machine learning, data science, automation, scientific research, you name it.
Okay, let's dive into some of those real-world applications.
Well, AI is probably the biggest one right now. It's changing everything, and Python is at the heart of a lot of these advancements.
Yeah, AI is everywhere. Self-driving cars, personalized recommendations, even helping with medical diagnoses. It's having a huge impact.
It really is, and Python's libraries are making it easier for people to build and use AI systems.
So Python's making AI more accessible, which means more people can contribute to this rapidly evolving field.
Exactly. And it's not just about building those complex AI systems. Python is being used to automate tasks in all sorts of industries: manufacturing, finance, healthcare, education. It frees up people to focus on more creative and strategic work.
Python's helping us work smarter, not harder.
Exactly. And in data science, Python's helping businesses make better decisions and understand their customers in new ways.
It's all about turning data into actionable insights.
Precisely. Even in scientific research, Python's being used to analyze data from experiments, simulations, observations. It's helping scientists study climate change, map the human genome, even explore space.
It's amazing to think that this one language is being used to tackle such huge challenges.
It really is. It shows just how versatile and powerful Python is.
So it's not just a language for coders anymore. It's for anyone who wants to solve problems, create something new, and make a real difference.
That's a great way to put it. And with how accessible it is, its supportive community, and all the tools available, Python's going to continue to shape the future in so many ways.
This has been an incredible exploration of Python's impact. It's clear that this language is much more than just code. It's driving innovation, problem solving, positive change.
It's amazing what humans can achieve when they have the right tools and a passion for exploration and discovery.
Now, let's shift gears a bit and talk about the practical side of things.
Okay, let's get hands-on.
How can someone who's been inspired by everything we've talked about take that first step and start building their own Python projects?
It all starts with choosing a project that excites you, right? What
Mm.
problem do you want to solve? What do you want to create?
That's an exciting question to think about.
It is. And remember, it doesn't have to be this huge, complex project. Start small, find something that genuinely interests you, and build from there.
So what are some examples of those beginner-friendly projects?
If you're into web development, you could create a simple website using Flask or Django. Or maybe build a web scraper to pull information from your favorite sites.
Fun and practical. What about for data analysis?
Download a data set from Kaggle, there are tons there, and then use pandas and matplotlib to analyze it and create some visualizations.
That's a great way to get a taste of what data analysis is all about.
It is. And if you're feeling adventurous, you could even build a simple machine learning model with scikit-learn.
It's incredible how accessible machine learning has become.
It really is. The key is to break down your project into smaller steps and celebrate those milestones along the way.
Choose a project, break it down, and dive in.
Exactly. Now, before you start coding, you'll need to set up your development environment. That just means installing Python and the necessary libraries on your computer.
Setting up a development environment, that sounds kind of intimidating.
It might sound technical, but it's actually pretty straightforward. There's so many tutorials online that can walk you through it step by step.
That's good to know. So once your environment is set up, what's next?
Then the fun begins. Start writing code, running your programs, and watching your ideas come to life. And remember, you're not alone. There's a whole world of resources and a supportive community out there to help you.
It's amazing to think that anyone can learn to code and create amazing things with Python.
It really is. The possibilities are endless.
Choose your project, set up your environment, and let the coding adventures begin.
Exactly. Don't be afraid to experiment and make mistakes. That's how you learn.
Well said. Now, before we move on to the next part of our deep dive, here's the challenge for you. Think about that Python project you're excited about. What's the very first step you need to take to make it a reality?
That's a great question to consider. Remember, the first step is often the hardest, but it's also the most important. So take that leap and start your coding journey.
Until next time, happy coding. You know, it's really inspiring to see how welcoming the Python community is. It's like a global family of people from all walks of life who just love Python.
It's incredible. Python has really broken down those barriers, making coding accessible to everyone, no matter your background.
And that diversity, all those different perspectives, that's what makes it so innovative.
Oh, absolutely. I was just reading about a group of marine biologists using Python to analyze underwater acoustic recordings. They're using it to track endangered whales.
Wow. Python giving a voice to the ocean's giants. What other surprising uses have you seen?
Well, in the art world, There's a whole movement of digital artists using Python to create generative art. Basically, algorithms that create unique visual pieces.
So Python's not just for crunching numbers and automating tasks, it's a tool for artistic expression, too.
Exactly. And even in history, researchers are using Python to analyze huge collections of historical documents. They're uncovering hidden connections and patterns that you'd never find manually.
It's like Python's helping us rewrite history, revealing those hidden stories.
It's amazing, isn't it, how it bridges so many different fields.
We've talked about all the incredible things Python can do, but what about the challenges? Are there any downsides or limitations that someone should be aware of?
It's a good question, and it's important to be realistic. One thing that can trip people up, especially if they're coming from other programming languages, is something called the Global Interpreter Lock, or GIL for short.
The GIL sounds mysterious. What's that all about?
It's a mechanism that prevents multiple threads from running Python code at the same time. It keeps things simple in many ways, but it can also limit performance for certain applications, especially those that rely on multi-threading to really maximize processing power.
So for someone working with tasks that need a lot of processing power, speed is critical. The GIL might be a factor to consider.
It's something to be aware of, yes, but there are ways to work around it, like using multiprocessing instead of multi-threading, or using libraries that release the GIL for specific operations.
It sounds like the GIL is something you learn to navigate as you become more experienced. What other challenges might someone come across?
Another one that can be tricky is Python's dynamic typing system. It's a huge part of what makes Python so easy to use, but it can also lead to errors that pop up while your program is running if you're not careful about how you manage different types of data.
Hold on, didn't you say earlier that dynamic typing was one of Python's strengths? How can it be both a strength and a challenge?
It's the trade-off. Dynamic typing lets you write code quickly without explicitly declaring types, but it also means the interpreter won't catch those type errors until your program is already running.
So it's like a double-edged sword. Super flexible, but requires a bit more caution from the programmer. Any tips for avoiding those potential pitfalls?
Definitely. Using type hinting can help a lot. It's a feature that lets you add type annotations to your code. They don't change how your code runs, but they can help you find errors early on.
Like adding a safety net to catch those errors before they cause problems.
Exactly. And like any language, Python has its own stylistic conventions and best practices that can make your code more readable and easier to maintain.
We talked about best practices earlier, but any specific ones you'd recommend for writing really clean and elegant Python code?
A good place to start is PEP8, the official Python style guide. It covers things like naming conventions, indentation, line length, code organization. It helps you write code that's not just functional, but also pleasing to the eye.
So it's like a grammar and etiquette guide for Python.
I like that. And beyond style guidelines, there are principles like DRY, don't repeat yourself and kiss. Keep it simple, stupid.
Those are great. So memorable.
They are. They encourage you to write code that's efficient, clear, and easy to understand.
Well, this has been an amazing deep dive into the world of Python. We've explored so much, its impact on different industries, its strengths, its weaknesses, even some advanced concepts and best practices.
It's been quite a journey. I hope our listener feels ready to take that next step and start their own Python adventure.
Absolutely. Remember, learning Python is a journey, and it's just as important as the end goal. Embrace the challenges, celebrate the wins, and never stop exploring.
Couldn't have said it better myself. And as we wrap up this deep dive, I want to leave our listener with one final thought.
I'm all ears.
Python is more than just a programming language. It's a community, a movement, a force for change and innovation. So as you learn Python, connect with others, share your ideas, and contribute to this incredible ecosystem, you might even inspire the next generation of Python programmers.
That's a beautiful way to put it. Thank you so much for sharing your knowledge and passion with us.
It's been a pleasure.
And to our listeners, thank you for joining us on this deep dive into the world of Python. We hope you've enjoyed the journey.
Happy coding.